Okay, we're going to take notes on polynomial long division. And really, long division, you did that back in 3rd, 4th grade when you were dividing large numbers. When you're, any two numbers can be divided by long division. Okay, so here we go. So let's think about how we did this. We looked at the 4. We said it doesn't go into 3 a full time, so we looked at the 35. 4 goes into 35 8 times. Then you do 8 times 4, you get the 32, and then you subtract. So 35 minus 32 is 3, and you bring down the 6, right? Then 4 goes into 36 9 times. 9 times 4 is 36. So that makes 0, but you're not done yet because you got to bring down the 8. And then 4 goes into 8 2 times. Then 2 times 4 is 8, and you get 0. So there's no remainder here. Remember doing remainders way back when. And there you go. Now here, this one, 12 doesn't go into 5, but it goes into 54. How many times? 4 times. 4 times 12 is 48. 54 minus 48 is 6. Bring down the 0. And 12 goes into 60 5 times. 5 times 12 is 60. No remainder. Okay, so we can do the same exact thing because we haven't divided polynomials. We added, subtracted, and we multiplied them, but now we can divide polynomials. Okay, so here we go. And really what this question is asking, and you might figure this out, it's looking for this unknown. All right, back up here, 45 times 12 equals 540. Okay, that's how you check to see if you were right back in the day. Or 892 times 4 should equal, what's underneath. Same thing. Whatever I get up here, when I figure this out, x plus 2 times something will give me 3x squared plus 10x plus 8. All right, so you can kind of guess and check and think what would work. Obviously, this is going to have to be a 3. And then you can play around with what needs to go here, without doing this whole division thing. But let me show you kind of the foolproof way of using division itself. Okay, just like long division always works with regular numbers. So basically we're just looking at the first coefficient. So x goes into 3x squared how many times? Well, if I do 3x, think about it. 3x times x gives me 3x squared. Okay, now, when I multiply the 3x times x, I get 3x squared, but now I have 3x plus 2, or times 2, I have 6x. So I multiply 3x times x plus 2, basically. Alright, so hopefully you see how I got that. 3x times x is 3x squared, 3x times 2 is 6x. And then I subtract. Subtract down, that's 0, obviously. And then I get 4x plus, and I'm going to bring down the 8. Again, x goes into 4x 4 times, and 4 times x is 4x. 4 times 2 is 8. They both make 0. No remainder. What? Okay, my son is sick, and he just puked, so I gotta go help. Okay, I'm back. But basically, to see if you're right, FOIL. Basically, this times this should equal what's underneath. And if you do that, you'll see that you're correct. So here, how about this one? So 7x goes into 28x squared 4 times, or 4x times. Because when I do 4x times 7x, I get 28x squared. Subtract, alright, and I'd make 0, so I bring this down. I get 48x. Oh wait, my bad. Scratch that. So I do 4x times 7x, I get 28x squared. Then I have to do 4x times negative 2, that's negative 8x. Now this is where you got to be a little careful here, because 48x minus a negative 8. So don't just add these. That's not 40. Okay, you're not subtracting those two. You're subtracting 48 minus 8. So that's actually a double negative that makes a positive. So that becomes 56x. Okay, and then bring this down to negative 16. Alright, so 7x goes into 56x 8 times, and 8 times 7x is 56x. That's what we wanted. That makes 0. But then when you do 8 times negative 2, you also get negative 16. And when negative 16 minus negative 16 is 0. So you're done. 7x minus 2 times 4x plus 8 needs to equal 28x squared plus 48x minus 16. Okay, so sometimes, disregard what's on this paper, but sometimes you'll see a division problem stated as a fraction, and that's no big deal. I mean, back when you first started dividing, sometimes, that's 10 divided by 2, that makes 5, right? So we've done this before where, a fraction is just division, obviously. Okay, so if you're given a question like this, you can always just throw it in long division. Okay, and I do this one because this is really a monomial. This is a one term going into a 3-term deal, but still not that hard. So 3 goes into 6 twice. Okay, x goes into x to the 4th. Think about it. What would I have to multiply by to get x to the 4th? X to the 3rd. X to the 3rd times x gives me x to the 4th. So same thing here. Y squared times y would give me y cubed. So just multiply that out and make sure you're getting exactly what you need. X squared times y is y cubed. See, and that's going to cancel out. Okay, when you go to subtract. Alright, so 3 goes into 4, or 3 goes into 12 4 times. X goes into x squared, or x cubed. X squared times y goes into y squared y. Because when you multiply it back through, you'll get 12. X squared times x is x cubed. Y times y is y squared. So again, it's canceling out. 3 goes into negative 18. Negative 6 times. X times x gives me x squared, and y times nothing gives me y. So when I multiply this out, I get negative 18. X times x is x squared, and basically 1 times y is y. And it all works out. These all cancel out, so we're done. So again, this times what's up top should equal what's underneath. Okay, and then lastly, you'll see division problems written like this, which, just using the division sign. So when you set it up, you put the second one here, what's being divided underneath. So x goes into x squared x times, because x times x is x squared. X times negative 1 is negative 1x. Now, some of you are going to be tempted to put negative 14 here. You got to be careful, you're subtracting. So negative 13 minus a negative 1, so it's a double negative, so it's like plus 1. You actually get negative 12x. Bring this down, you get plus 12. Okay, so x goes into negative 12x negative 12 times. So negative 12 times x is negative 12x, and negative 12 times negative 1 is positive 12. And guess what? When you subtract those, you get 0. So there is no remainder. So x minus 1 times x minus 12 must equal 13x plus 12. Negative 13x plus 12. If you check it out, you see that it does. So you're going to do a series of problems like this. Go back to this video if you need to. It should be on YouTube. So reference that on your homework.